Hello and welcome back to the Python OOP series. In the previous video, we learned about encapsulation, different types of attributes, getters, setters, and how to protect an object's internal data. Today, we will be moving into another fundamental pillar of object-oriented programming called inheritance. Inheritance allows us to create new classes based on existing classes. Instead of writing the same code over and over again, we can build on top of classes we've already created. This is a concept you'll see everywhere in production software, whether you're building banking systems, healthcare platforms, e-commerce applications, or machine learning systems. By the end of this video, you'll understand what inheritance is, why it exists, how to create subclasses, and how Python finds methods using something called method resolution order or MRO. Now, let's start with the problem inheritance solves. Imagine you're building a company management system. You create an employee class containing a name, email, and an employee ID. Now the business needs developers, then managers, then HR employees. Without inheritance, you'd end up copying the same attributes and methods into multiple classes. This creates duplicated code. Duplicated code is expensive because every future change must be repeated in multiple places. Experienced software developers and engineers try to avoid this duplication whenever possible. Inheritance exists to solve this problem. It allows a child class to reuse functionality from a parent class while still adding to its own behavior. So, what exactly is inheritance? Inheritance is a mechanism that allows one class to acquire attributes and methods from another class. The original class is called the parent class. You may also hear terms like base class or a superclass. The new class is called a child class or a subclass. The child automatically gains access to everything defined in the parent. Now, why is this useful? Because software systems often contain objects that share common functionality. Rather than rewriting the functionality over and over, inheritance allows us to define it once and reuse it everywhere. This leads to a cleaner code base and easier maintenance. When deciding whether inheritance should be used, experienced engineers and developers often ask one simple question. Does an is-a relationship exist? For example, a developer is an employee, a manager is an employee, an admin user is a user account. These are valid inheritance relationships. Now consider this example. A user account has a password. That is not an is-a relationship. A user account is not a password. That has a relationship. A common beginner mistake is using inheritance where composition should be used instead. Inheritance should only be used when the child is a more specialized version of the parent. Now, we shall be implementing an inheritance example. Here, we'll create a user account class and then create an admin user that inherits from it. This is much closer to what you'd see in a real application. So we go class user account. Now we define a method login, pass self, and print user logged in. Now we create another class called admin user. We open the parentheses and we send user account as the parent class and we pass. Now what we can do is we can create an admin user object, and if we call admin.login, if I run this code, we can see that user is logged in even though nothing is defined here in admin user. This is because the admin user class, which is the child class, has access to everything the parent class consists. Now, we can implement whatever function here as well. Def logout. We call self. We simply print user logged out. Now, if we call admin.log out and we print, we get user logged in and user logged out. However, let's create a user object and Let's call user.logout. Let's see what happens here. We get an error saying user logout object has no attribute logout. This means that the parent has no access to the child's methods. However, the child does have access to the parent's method. Now, what we just saw is called method inheritance. The login method only exists inside user account. However, admin user can still use it. This becomes extremely useful in production systems. For example, you might have user account, admin user, customer user, and support user. All of them can inherit common functionality such as login, logout, password reset, profile updates, etc. Instead of writing those methods multiple times, they can live in one parent class. This reduces maintenance and improves consistency across the system. Now, how does Python search for methods? Now, Python follows a specific search order. First, it checks the child class. If the method isn't found there, Python moves to the parent class. If it still isn't found there, Python continues moving upward through the inheritance hierarchy. The search path is called the method resolution order, or MRO. Understanding MRO becomes very important once you start working with larger applications and more advanced inheritance structures. Now, let's see what method resolution order actually looks like. Now, let me comment these out and let me write print admin user dot double underscore MRO double underscore. Now, MRO is a dunder method, which we shall be looking on further in the series. Now, if I print this is what I get. Now, Python tells us exactly where it will search. First, it will search the admin user, then user account, then the built-in object class. This means if Python cannot find something in admin user, it automatically moves up to user account. And if it still can't find, it checks object. Experienced engineers often inspect the MRO when debugging complex inheritance hierarchies because it reveals exactly how Python resolves methods. Now, let's have a look at a common AI application example. Imagine you're building a machine learning platform. I presume everyone knows what machine learning is at this point. We create a base model class. The model class might contain functionality such as a train method to train the model, a save method to save the model, or a load method to load the model. Here, we create our own specialized models as children class, such as a classification model, a generator model, a recommendation model, a regression model, etc. All of these are models. This means that they can inherit common functionality from the parent class, which is model. The specialized classes only need to implement features unique to themselves. This approach is heavily used in frameworks such as TensorFlow, PyTorch, and many enterprise-grade machine learning platforms. Inheritance helps developers build scalable systems without constantly rewriting the code. Now, let's quickly recap what we've learned today. Inheritance allows one class to reuse functionality from another class. A parent class provides common functionality. A child class inherits that functionality. Inheritance should model and is a relationship. Python uses the method resolution order, or MRO, to determine where methods should be searched. And inheritance is widely used in real-world software systems to reduce duplication and improve maintainability. Now, in this lesson, we learned how inheritance allows child classes to reuse functionality from their parent classes. We created our first subclass, saw inherited methods in action, and learned how Python searches through the inheritance hierarchy using MRO. In the next video, we'll make inheritance even more useful by learning method overriding and the super function. We'll see how child classes can customize parent behavior while still reusing existing code. I'll see you in the next lesson.